Hello everybody, long time no see. Today I will do the practice for the system design question, design Ticketmaster. So let me get started with the functional requirement. Okay, the first thing I can say, or I should say, the first thing user should be able to do is user can search for event. So maybe the event like the live concert of Taylor Swift, or maybe the baseball, match. So user can search for events. And the second thing user should be able to do is obviously user can book the ticket. So user can book a ticket for a seat. So in the case of Ticketmaster, user can specify an exact seat. So it likes a seat number like 16A or something. Not like, oh, I'd like to guess the, S seat or S class seat, or A class seat or something like that. Not something like that. Okay, so, and the last thing I'd like to include in the functional requirement is, oh, wait. Before user can book a ticket, obviously user can be see the event and the seats available. Or I should say, user can see the event detail and the seat available there. Okay. And number 3, user can book a ticket for a seat. Okay, so this is the functional requirement I will include. And for non-functional requirement, so first thing I'd like to talk about is about the CAP theory. So CAP theory is consistency versus availability versus partition tolerance. And out of these 3, I can guarantee up to 2. So because we are developing designing the distributed system, partition tolerance is a must. So I have to choose from consistency or availability. And for this Ticketmaster, I have to be very careful when, especially for the booking. So when booking, let's see there is a seat available, and there are 2 kind of client, or I should say process, which sees that the seat is available. And the next moment, these 2 overwrite that kind of DB record that the seat is occupied, or booked by that user A, and also at the same time user B. In that case, it obviously is a double booking. So yeah, the ticket is, issued for 2 users maybe, and then these 2 users go to the same seat, and that's a big problem. So when I think of the booking, I have to guarantee the strong consistency. So I would say ticket booking. However, I don't need the strong consistency for, let's see, the event detail. Let's say there is an event description, and event description has a typo and it is updated by the admin user. In this case, a user doesn't have to see that change immediately. So this means that the client doesn't have to read the latest right. So I don't need the or I should say, eventual consistency is available for others. So I would say or I should say like this. Okay, so this is the first functional requirement. And let me think of the second functional requirement. So maybe I will talk about the latency. So low latency, like 500 millisec for each operation. Yeah, when user searches the event detail should be displayed in 500 millisec, and event detail should be displayed within 500 millisec on the browser of the user, and booking should be done within 500 millisec. Yeah. Okay. And aside from that, let me see. Okay, so the last one, I will talk about the scalability. So I put it here. So scalable to 100 million daily active users and 100K event. Let me check my note quickly. 100K event per day. Yep. And also should be the spike. Yeah, this one. So let me share a quick note on this. So 100K spikes for viewing and bookings. So basically this system, Ticketmaster, has the spikes. So for example, let's say there is a baseball match in the Dodger Stadium, and there, I don't know, maybe 50,000 users inside of the stadium. I don't know, but yeah, obviously let's think there are so many users and they'd like to go back to their house, go to their home, and they'd like to, after the game is ended, so many users search for the no, sorry, I was talking about Uber system. So okay, in the Ticketmaster system, spikes occur when, let's say, Taylor Swift or maybe Paul McCartney does a tour and they shares the new information about the new event. So in that case, there should be the spike because there's so many users searching for Taylor Swift and they try to book a ticket at the same time. So that's a spike here. Okay. So now I will talk about the core entities. So core entity is like the DB table, DB schema. So yeah, first we have users, we have event. Obviously for the event, we have the kind of venue, or I should say, place or stadium, and also we should have seat, booking, these are the places I need. So place has many seats. Wait, place, how should I call this? Let me check my note. Venue, okay. So these are the things I have to take care. So user makes the booking for the event, and the event is, held in the venue, like Dodger Stadium, Tokyo Stadium, and each stadium, or just each venue has many seats, and user makes the bookings. Okay. And now I will talk about the API design. So for functional requirement, I will take a look at each functional requirement. So number one, user can search for event. So here we need the backend API which fetches the event from the search condition user input in the UI. So I would say get event API. So for here, I will use the REST API. So get events, and I need search conditions like maybe date and area, or I should say, yeah, maybe area should be like country or something like that. And also obviously we need the search words. Good. What else? Event data area, no, sorry, date. I would say place and words. Okay. Words, search, keywords, yeah. Okay, so these are the search condition. Obviously, this can have so many others. Like let's say we should have the enum of the performers, like Taylor Swift, Paul McCartney, and maybe we should allow the front-end application to specify the enum value here. But I don't talk deeper than this for now. Okay, so this should return the list of events. But yeah, I don't talk more about this for now, but what I can tell is it doesn't have to include all the information about the event. So maybe description is not needed because frontend now shows the list of events in the search page, search result page. So each item should have a small space in the UI, so we don't have to include all the information of the event in this API response. Okay. Number two, to realize this functional requirement, user can see the event detail and the theta variable. I need the get event detail API. So the front-end app specifies the event ID, and now what is returned. So I would say obviously I should return the event. And also it depends on the UI or UX of the application, but this should also have the theta variable. It totally depends if I should separate get seed and get event according to the UX, or maybe not. Maybe I'd like to separate them because I can expect that if I'd like to return the seeds available, or I should say all the list of the seeds and the flag, if each of them is available or not, it's a kind of big data because maybe student has maybe 50,000 of seats. So I would separate the API in this way. Firstly, frontend can display the event detail, and then asynchronously fetches the seed available. Sorry, all the seed of that event, and then UI can fetch it asynchronously and render it in the UI. So now this returns list of seed. Okay. And now I can satisfy this function requirement number 2. So I will go to function requirement number 3. User can book a ticket for a seat. I think this is the most important one. So I use the put and I use the event. Maybe I don't need it because seed ID should be unique across all the event. In that way, I don't need the prefix like event/id. So now I say seed./id, and then the entity I'd like to create is the booking, and I try to put this one. No, I will use put post because I'd like to create this entity. Yeah. If I use the put, obviously this means that the booking entity is updated, but what I'd like to, create the entity, so I use the post API. Then it should return. If it could be created, it should return 200, maybe just 204 success without any response body, or if this wasn't possible, it should return 400, 403, no, authorization, 400, which was it? Body request, 400. Let me check. I completely forgot. Yeah. So okay, I did a quick search. I should return 400. Okay, in the case booking failed. Obviously this happens when the seat looks available to the user, but there are two users who book the seat almost at the same time, and the latter user fails. Okay, now I will work on the high level design. So I will try to realize these APIs one by one. So there is a user, or I should say front end app, and he'd like to make the reservation. So for the get event API, user makes the request to the event service. Okay. And obviously, this should fetch the event data from event.db. Okay, and returns it. So this event service makes a query to event.db so that it can fetch record, event record, which applies to the specified conditions. So this should have the events table, which should have event ID, date, description, and venue, etc. Okay, good. But there is obviously a problem here, that if I'd like to use the keyword search, I have to scan all the records in the event table. So what I need here is inverted index. So from the keyword, I try to get the list of events whose description includes those search keywords. So for that, I will use the Elasticsearch. So Elasticsearch has the inverted index and also just pager index. So price, price search by price is very well handled by Elasticsearch. Yeah. And so what I can suggest is fetches the data from Elasticsearch. And then how the data is inserted into the Elasticsearch. So the first thing I have to think of who creates the event. Obviously, it should be admin user. So when admin user creates the event in the event DB, then this should be asynchronously, propagated into Elasticsearch. I shouldn't use the Elasticsearch as the main DB because Elasticsearch is, Power Built DB for the searching. It's not built for the main DB. Like PostgreSQL. PostgreSQL has a higher, better reliability, availability. So I definitely should use Elasticsearch as the, additional layer. Okay, so what else? I need the get event API for this one. Event service can fetch the event directly from event.db because event to be fetched is specified with the ID. So yeah, if I use the relational database like PostgreSQL, I can use the primary key on the ID, and this internally creates the B plus tree index. So it takes the record in overbroken time. Yeah. So let's use PostgreSQL because at this moment there isn't specific requirement which I have to choose out of NoSQL like DynamoDB, Cassandra. So I'd like to use the most common one. But maybe I will update this later when for the scalability or for other non-functional requirements. Okay. Now I need the get seeds. So from here, I'd like to think of something. So how should I handle each seed? So the first thing I can say is if I need to create the seed table, and the answer is yes, I will create it. Even they need the so this is good. I will create okay, what's the user ID? So, and let me say for now this is primary DB. So I will create seat table here. This user ID is the user who booked this seat, and I will go with this. So instead of creating the booking record, I create the seat record, and seat has the user ID and booked ID. So if I'd like to get the seat booking of the specific user, I can take a look at the seat table record. And yeah, booked ID, what is it? Booked out. And for example, if there is some additional seat, admin user should create more seat records. So okay, let me just clarify. So when admin user creates the event, they also create seat records, like 10,000 or maybe 50,000 seat record in a batch shell. Okay, and now get seat table, so get seat API should fetch the seat available from this seat table by specifying the event ID. So I need the index. I need the index here. Okay. Next, book seat. So for now, I don't take care of the double booking. So what I can do is book seat should update the user ID and booked at of the seat table. So this is a write query. This is the only write query out of these 4 queries. Okay. Good. Now I'm done with the API implementation. So I take a look at the non-functional requirements. So the first one, strong consistency on ticket booking. Okay. So yeah, as I said, the problem occurs when there are 2 clients who tries to book seat, write query onto the same seat table. So yeah, I can say this is obviously what was it? Okay, so sorry. So yeah, I need to avoid the kind of contention, double booking here. So let me firstly clarify what's happening when user makes the double booking. So what the problem is, user A, or just the client A, or maybe process A, reads seat record and find user ID is null. And this happens, for another process, B, and ordinarily what happens is, here process A writes user ID booked at on that seat record. And also process B does the same for the same, yeah. So in this way, if those event occurs in this order, there's no double booking. But the problem here is, if there are 2 users with the same record, and if this occurs after this, the problem occurs. And I have to avoid this situation. Okay, so basically I can, avoid this kind of contention issue by using the DB. Yeah, actually now I think PostgreSQL is a very good choice because relational database has a strong consistency support built in. So let me tell you what I can use. So the first thing I can use is using the transaction of the DB. We should say DB rock, sorry. So this is the pseudocode. It starts transaction and then lock the record with select update. So in this way, record X is locked. So no other user can update this record. And then update user ID and booked out here. Then end the transaction. So what happens here is that when this select for update is done, this seed X record is locked, as I said. So what happens is user B can read it, but wait a minute, user B can't read it. Let me think, maybe I was wrong. User select for update. So when I do select for update, others can read. Okay, sorry, now I remember, yes. So when I do the transaction, let me remember. So, okay, so I took a quick look at my note and let me delete this and start the explanation of the solutions again. Okay, so I have three solutions here, basically for the this kind of double booking contention problem. So number one is set the DB isolation level to serializable. So what happens with serializable is when multiple requests arrives as a database kind of asks them to wait in a queue, and each request is processed one by one. So this is, yeah, very strictly saying that linearizable, complete requests are not waiting in the queue completely one by one, basically. But I can say with serializable level, in the end, when I look back to each DB operations, I can think of them as if they happened one by one. So they don't affect each other. So that's the serializable level. I will talk about pros and cons later after introducing three solutions. So number two is what is called pessimistic rock. So in this pessimistic rocking. And number 3 is optimistic concurrency control. So this number 2 is something which uses in transaction. And I use the select for update to select this record X and then throws update query. And end the transaction. So what happens here is that when I do select for update here, so this part makes each transaction, each request which does select for update has to wait in the queue. Yeah, so I can say if I use the serializable isolation, all the requests, no matter it is about the record X or not, has to wait in the queue. But for this number 2 approach, only for the request which is trying to read record X, they have to wait in the queue. So each seed record has the kind of queue of request. So that's the pessimistic rocking. And number 3, optimistic concurrency control. So this introduces a kind of version key to the seed table. So version column, which should be default 0. And every time, I should say, so okay, so what I can do is, okay, so with optimistic concurrency control, the client has to make 2 queries, throw 2 queries. Firstly, reads the seed record and gets the latest version, and they try to update seeds where version is current number, let's say 3, with user ID booked at, and version is number 4. So what happens here is that firstly, the process, so the version ID is 3, and when next 3, when it makes the update query, this where version 3 guarantees that there are no other process who's updated this record until the last read query from this process. So in this way, I can avoid the double booking. Okay, so this is the number 3. So out of these options, I would choose, Okay, maybe I should compare the differences as I said earlier. So firstly, I can say this one I don't have to use it because pessimistic rocking, I mean, for each seat record is enough. I don't have to, block the whole DB right just for the one seat update. So pessimistic rocking is now the option, and optimistic concurrency control is also the option. But obviously, because we have to lock the record, pessimistic rocking is more, less scalable. And for optimistic concurrency control, this is basically good, but the problem is this one. So if there is a, double booking, the query number 2 fails. So the client has to retry and retry and retry until it finally can fetch the it can finally update the record. But in this case, we don't have to take care of the retry, because if the seat is taken by someone, then that seat is not available anymore. So we just have to return the user that the booking failed, and user have to choose the other seat, another seat. So basically, the biggest problem of optimistic concurrency control isn't the problem here. So that being said, I choose the optimistic concurrency control for this question. No need for locking. Okay, so I go with this. Good. So in this way, I can avoid the double bookings. Now strong consistency is guaranteed for seat booking. And other ones, so availability. Okay, so now let's say we'd like to guarantee the availability. Oh, by the way, I forgot to say, but this is API gateway. This does the authentication, sometimes load balancing, sometimes routing to each microservice. Yeah. Okay. Oh, by the way, maybe I should separate this, book seat service. I do so. Yeah. This is because I'd like to, scale this service separately. And also, even if the booking fails, I'd like to, keep event service, maybe event search, get event should keep working. So this is why I separate these two services. I was a bit late, but I make this update now. Okay, and so availability. So for the availability, I'd like to have a kind of redundancy. So I will introduce the scaling here. So I reduce the scaling and make sure that there are maybe 2 or more services here, so that even if one server dies, others are living. And also for API gateway, actually this is I can think of this as the kind of cluster of servers. So internally, this is redundant. And for Elasticsearch, I can use the option to make it, make the replicas. And also primary DB, I can use the read replicas. And what I can do is enable the old failover from read replica to write node, primary node, automatically if read replica dies. So in that way, a service becomes available for write queries after maybe 10 seconds or maybe a few seconds of failover. Okay, so I'm a bit tired. It's Sunday night here. So I will talk about the scalability in the next video, and also I will have some deep dive questions I will introduce. So also I will talk about them in other videos. Anyway, I'm so happy that I can post this video maybe after half a year. I will keep posting system design practices because I think it's the most important thing for me now. So thank you so much. Have a good day. Bye.